The last thing I'd like to talk to you about today are inequalities and how we can use them to solve some real-world kind of problems as far as finding optimal solutions. A lot of times we like to do things in such a way that we, for example, maximize profit, minimize waste, and we have to work within certain constraints. That could be a difficult thing to figure out by trial and error. I mean, you can just try everything that's possible, but never know that you've got the best answer. Well, here's a way, using inequalities, that we can go through and find the best answer to get the optimal answer to problems like that. Here's the example that I'm going to work with you is, let's say you're helping the band boosters or some other civic club, and you're helping out by baking cookies or brownies for them to sell at their next event. And you've told them, so I can devote 10 hours to the project, but then I've got to do my other stuff. And so that's a constraint. You're only going to spend 10 hours on the baking. And then the other constraint that we have to kind of worry about is you only have 8 trays that you can provide full of cookies or brownies, whichever it is. Now, there are certain things to take into account here. Let me kind of point to them. I can bake cookies faster than I can bake brownies. I can fill a tray with cookies in about 45 minutes, although it takes me about 2 hours to fill a tray with brownies. So, the question here is, well, which is better? Should I try to just make, in 2 hours I could make 5 trays of brownies. Should I do that? It turns out that I can profit by $18 on each tray of brownies. That's more than $10 that I profit on each tray of cookies. Maybe I should just do that. On the other hand, I could definitely fill all of my trays here with cookies in the 10 hours allotted. So the question then becomes, okay, what mix of trays of cookies and trays of brownies would be best to produce the most profit? And that's, if you're going to work on this, that's what you want to do. You want to get the biggest bang for your effort. You want to get the money out of it. So let's talk about how we set this up. We're actually going to set up the constraints. We're going to use a graph now, and we're going to graph. I'm going to let X be one thing, number of trays of cookies. I'll let Y be the number of trays of brownies. And let's actually kind of graph the set of valid answers that I could look at. So my constraints, the obvious constraints on X and Y, X for the number of trays of cookies, Y for the number of trays of brownies, is that they both have, I can't have negative trays of cookies or brownies. So I'm talking about working here in this first quadrant. Definitely things have to be here. But if I start to look at the other constraints, the time constraint is that I have a maximum of 10 hours to spend on this project. I can spend, it takes me 45 minutes to fill a tray with brownies, so that's 3/4 of an hour. I'm doing things in terms of hours. And it takes me 2 hours to construct or put together, bake a tray of brownies. So depending on what X is, however many trays of cookies I have, I'm going to multiply by 3/4. However many trays of brownies I have, I'm going to multiply by 2. And now let's put this on our graph. I actually need to solve for Y. So I'll bring all the other stuff over, divide by 2 real quick, and then I'll graph that. And because this is Y less than this amount, I'll graph this line, and then I'll take the bottom half, or the bottom part of my graph. So I've actually eliminated a lot of the solutions I had earlier. Okay? Definitely things have to fall within this triangle. The valid answers would have to fall inside this triangle. The other constraint is the number of trays. Well, X plus Y cannot be bigger than 8. I've got 8 trays, that's it, that's all I've got to work with. So I'll graph this as well. Y is less than or equal to 8 minus X. I'll graph 8 minus X, which is actually going to be right through here. And again, I'll take things under it, but I want things that overlap what's already shaded. So watch this, I'll put the graph in. There you've got some overlap. Yeah, we probably go back and show this. So I've eliminated now, let me show you the part. This part was in there, but now it's eliminated. So what we have here, this light blue business, that's the set of valid answers. My answer has to come out of this. And what I would claim to you folks is that to find the optimal answers that will maximize profit, I just need to look at these corners of the polygon. It's a quadrilateral. Okay? And let me show you why that's the case. If you think about the profit that we're going to make on this, it would be a certain amount for every tray of cookies and a certain amount for every tray of brownies. Well, that, if you graph that in 3-space, you've got X is something, Y is something, and you take that amount and graph that on the Z-axis. You kind of think about, here's everything happening in the plane, and then the amount that I get for X and Y, put that on the Z-axis. So you get a 3-dimensional graph. Well, there's different things that can happen. You can have things where it only grows in the X direction. In that case, this would be the highest point. That's directly above this corner of the polygon. Or it could only grow in the Y direction, okay, in which case this would be the highest point on the polygon. Or, as is the case in our problem, it could grow a little bit in each direction, and it's kind of slanted there, in which case this is the highest point on the polygon. And it's kind of hard to see that the way the things, let me move the graph up just a little bit so you can see. Change the perspective on it, see that that is now the highest point on the graph. Okay? So what we've got to do now is take our profit function. I profit $10 for every tray of cookies and $18 for every tray of brownies. And you know, I don't really want to worry about what the graph looks like, but I just want to check the corners. I know that this is a plane in 3-space, whatever, but I just have to check the corners. Even if it's constant along, you know, if one of these lines happen to be level, I could still check the endpoints and get the same value. So it's sufficient just to check the corners. So that's what I'm going to do. The only constraint that I really have here is that the corners may not be whole numbers. And I kind of need to think about doing whole number trays of things. So instead of 4.8 and 3.2, that's where these things actually kind of hit each other. I'm going to look at whole number answers just inside the polygon. Like 4.3 and 5.3 are inside the polygon. 4.4 is not. 4.4 would be about right here. And that's actually outside the blue region. So we just check the amounts. At 0, 0, I get 0. That makes sense. If I don't do any trays, I don't get any money. If I do all cookies, I get $80. If I mix them up and do 4 and 3, I get $94 profit. If I do 5 and 3, that is this point closest to that, I get $104. And if I do all brownies, I just get $90. So the maximum answer, the maximum mix is do 5 trays of cookies, do 3 trays of brownies. That will maximize the amount of profit that I can get from this endeavor. Neat little application of inequalities, and just plugging into a formula just to get your maximum answer. I'm going to flash up some graphs that kind of show the kind of things that I was doing as a summary, and we'll come back in just a moment and wrap things up.